Today we're going to look at parent functions. The most basic function in a function family is called a parent function. There are 5 functions that we study in Algebra 1, and those include linear, quadratic, absolute value, square root, and exponential. Now, there are many more functions, but these are the main ones that we do study. So we like to learn these right away at the beginning of the course. And as you go through the course, you will learn more things about each one of these types of functions. The first, and the one you probably already know best, is the linear parent function. The most basic equation you can write for the linear function is y is equal to x. So this is your parent function. You will create a table of solutions to create a graph of this function. So the 5 points I typically choose when I'm making this graph are the points -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. You'll notice that each y is equal to the x, which makes the equation true. Y is equal to x. When you plot those 5 points on a graph, you will connect the points because the domain of the linear parent function is all real numbers. So those are all plotted and you can see the connected line there. Now to get the domain in set notation for the linear parent function, you would basically write an inequality, or you would write some kind of expression to represent all the x coordinates that are on this line. Well, the line goes on forever in both directions and includes all these points and all the points in between them. So we would say that the domain of this function is all real numbers. So you'll notice here we have a little pink line to show that this goes left and right forever. You would write it x colon x is an element of the real numbers. That's what all real numbers looks like in set builder notation. The range are your y values. So as you'll notice, these y values start at the bottom, but they go down forever and go up, and they go up forever. So the line has a range of all real numbers. So you would write y colon y is an element of the real numbers, and this fancy R here is just a symbol that we use for real numbers. The quadratic parent function, we will spend a long time learning this right before state tests. So this is a very important function, and this function looks like this. Y is equal to x squared. To create a table of solutions, you can choose the same x coordinates that we chose for the linear function, -2, -1, 0, 1, 2, but you will square each of these numbers to get your y coordinates. So -2 squared is 4, -1 squared is 1, and so on. When you plot those 5 points and connect them, it will create what we call a parabola. This is also a continuous graph. We do want to connect the dots on the graph, and the domain for this graph is actually the same as the domain for the linear parent function, because the graph does go left forever and it goes right forever. So you would use the same notation and basically the same domain. The range, however, is not the same. For the range, you would start at 0, 0 and go up. So your range would include all the y coordinates that are greater than or equal to 0. So this is how you would write your range for your quadratic parent function in set builder notation. The absolute value parent function looks like this. Y is equal to the absolute value of x. The absolute value of a number is the distance that number is from 0 on a number line. It's always non-negative. It's impossible to have a negative absolute value come out negative. So if to create a table of solutions, we can use the same 5 x coordinates, but you'll notice that all the y coordinates are non-negative. So the -2, the absolute value would be +2. -1, the absolute value is +1, and so on. So when you graph this function, you'll notice that it makes this V shape, and that's one way to remember the name. Absolute value has a V, and the graph is shaped like a V. To do your domain for your parent function, it's actually the same domain that we used for the others. It would be all real numbers because this graph goes off to the left and to the right forever and includes all the numbers in between. So we would say x is an element of the real numbers. And then to do the range, well, this one is actually similar to the parabola we just saw with the quadratic function. It starts at 0 and it goes up. So we would say the range is y greater than or equal to 0. The square root parent function is the equation y is equal to square root of x. Now this one, we don't want to use all the numbers -2, -1, 0, 1, 2, because at -2, if you put a -2 under your square root, then your calculator will give you back an error message. That is not a real number, so you cannot take the square root of -2. And then the square root of -1 is not a real number either. So in the table, you'll notice I skipped some of these, and we've got 1, 1, 2, and then this is a question mark because square root of 2 is a decimal, so we'll leave that one out. But the square root of 4 is 2. And really all we have are 3 points to put on this graph, not very much. So if you'll plot those 3 points, what you really have is like a sideways parabola, but it's only half of it. So this is the shape of the graph. It's very different from the other parent functions. And the domain will be different from the other parent functions. The other functions went left and right forever, but this particular graph does not do that. It starts at 0 and goes off to the right forever. So we'll say that x is greater than or equal to 0. All the x's are to the right of 0 or they're equal to 0. The range in set notation is also greater than or equal to 0 because you would start at 0 and you go up forever. The next function and the last in the set is the exponential growth parent function. Now we're going to use the equation y is equal to 2 to the x power, but the base, which is 2 in this case, can really be any number greater than 1. The most common bases that we use for our exponential growth parent function are 2 and 10. So in the table, I am using the same 5 x values that we used for linear and for quadratic and for absolute value. And when you take 2 and raise it to the -2 power, we'll learn a little more about this later in the class, but that value is actually equal to 1/4. And I've got the calculation here for you if you want to see how that works. And then y to the -1 power is equal to 1/2. And then you'll notice the y values are doubling each time, which makes sense because you're multiplying by 2. When you graph this function, you will get a curved graph that is increasing that looks like this one. So for our domain, this does go off to the left forever, and it does go off to the right forever, and it includes all the numbers in between. So we'll say the domain in the set notation is all real numbers. X is an element of the real numbers. For the range in set notation, the y value is at 0 and goes up, but do you know it does not touch 0 at all? So when you write this in set notation, instead of saying y is greater than or equal to 0, you don't want to put the equal. You just want to say y is greater than 0. And that's because it's impossible to get a negative number out. It's impossible to get a 0 out when you raise 2 to a power. So your graph is only above your x-axis. Okay, so in summary, a parent function is the most basic function in a function family. The ones we studied in this presentation are linear, quadratic, absolute value, square root, and exponential. Be sure to study your 5 parent functions.